find the maximum or minimum value of this quadratic. Whenever we're finding the maximum or minimum value, you're always trying to find what is the highest or lowest point to which this quadratic either goes up to or down. And so that's the first thing we can determine here. When I look at a quadratic equation, I want to ask myself, is it opening up or is it perhaps opening down? I look to that leading coefficient. Here we have a -4. A -4, a negative leading coefficient, reminds me that this is a quadratic that has been reflected over the x-axis and is pointing down. And so it will have a maximum value. If this had been a positive leading coefficient, then my parabola would have had its normal opening up, and I would have hit a a minimum value on a regular parabola. So, finding the maximum or minimum value. I have my quadratics equation in standard form. Standard form doesn't tell me much about the location of where this parabola is on the graph. If I want to find the maximum value, I want to find its vertex. And so I want to change this standard form equation into vertex form. In order to do that, there's a process called completing the square. Completing the square is a stepwise process that works every time to take standard form quadratic equations and put them into vertex form, which will give us the coordinates of that maximum or minimum value. I'm going to pull this apart into many steps. You, when you get good at this, can skip some of these steps or do more than one step in a line, but for now I'll do one step per line. So the very first thing we do is we take a look at the first two terms. And in order to turn this into vertex form, I want an x squared set term that has no coefficient with it. So I'm going to factor this -4 out of each of these terms. Now, a reminder, factoring, or pulling this -4 out front, is essentially dividing it out of each term. So if I divide it out of this first term, -4 divided out of -4, I'll have my x squared all by itself, which is my goal. A -8 divided by that -4 means I have a positive 2x. And if I redistributed that -4 into the bracket, I would get back to where I started. Now I still have this 5 out back that I can't forget about. So step 1, factor away any leading coefficient, whether it's negative or positive. Then what I want to do is I want to force this to be a perfect square. Right now it's not. And I always ask myself two questions. I look at this term here and I ask myself, hey, what's half of that? Well, half of 2 is 1. I'm going to add that 1 in that is squared. But now I've just changed the value of the whole equation, so I need to subtract it out again. This portion of my bracket is what's going to become what we call a perfect square. And so what I want to do is I want to get this guy out of here. I call it buying it out of the bracket because everything in this bracket is subject to this -4. So I'm going to multiply this -1 times 1, which is a -1, multiplied by this -4 to buy him out of the bracket. So a negative times a negative is a positive. A 1 times 1 is 1 times this 4 is a 4, and I still have this 5 out here. And so I've just got a bracket that can become a perfect square. Now I will factor that and then put it together as my perfect square, but x times x becomes x squared. 1 times 1 becomes my 1 squared. My inside term is 1x, my outside term is 1x. That gives me that middle term of 2x as long as they're both positive. And so now I have achieved two factors identical, so a perfect square. And I've got my quadratic in vertex form. Now if you remember your transformations of your quadratics, a +1 inside my square sent this whole parabola left by 1 and up by 9. And so if I was to think about how that affects the parabola's position, it goes left by 1 and up by a 9. So perhaps a -1 there and a 9 there. I do know that it opens down. And so I've got a parabola opening down that its vertex went left by 1 to a position of -1 and up by 9. And so the vertex coordinates are right here, as long as I remember that it's an opposite sign. It went left by 1 and up by 9. So I have a maximum value of 9 at an x-coordinate of -1. To do one that's a little bit perhaps more challenging, it's the same steps. The very first thing I want to do is to focus in on those first two terms and divide out that leading coefficient. Now this time I'm dividing out a half. And so I ask myself, how many halves in a half? Well, that's 1. So let's pull it out here and I'll just have 1x squared left. How many halves in a 4 is one way to think about this. So there's 8 halves in a 4. Or if you like your fraction rules, I've got a -4 here that is being divided by a half. Well, we know that we never divide by a half, so I would invert and multiply, flip that fraction over, and I still get my -8. And I have my 6 over here. Now I'm going to open up that bracket and ask myself two questions. What's half of 8? -8 is there. What's half of 8? Well, that's 4. And what's 4 squared? Well, that's 16. I will add it in and take it out. I leave it as the squared because when I create my perfect square here, it comes back to the square root of that term to begin with. So why square it up if you're going to square root it down is how I choose to think about it. So I want my 4 squared in this bracket. I don't want this minus 4 squared. So 4 squared is 16, minus 4 squared would be -16, and I need to buy it out of the bracket. What's half of -16? That would be -8. And so now I think about factoring this term, or this expression, into two binomials. X times x gives me my x squared. 2 times 2 gives me my 4. Oh, sorry, 4 squared, not 2 times 2. That's a 16. 4 times 4 gives me my 4 squared, which is 16. And if I want a -8 out of that, both of these have to be negative so that I get my -4x, my -4x coming together to be -8x, and a -4 times a -4 is a +4 squared, or 16. -8 plus my 6 is -2. And so I finally have this parabola in vertex form. My vertex went left by 4, so right by 4. I'm trying to think. Right by 4, 1, 2, 3, 4, and down by 2, 1, 2. And so I think about my leading coefficient here is a positive value this time, and so it will be opening up. So this parabola has a minimum value, the lowest it ever goes is this -2. Its vertex coordinates are 4 and down 2, so a change of sign on this 4 and down 2. And so I have a minimum value of -2 at an x equals 4.